Hi everyone. So in this video session, I'm just gonna solve one question from digital logic, and I'm recording this video at 1:38 a.m. in the night, right? So this question was asked in GATE Electronics and Communication, and you know whatever concept is taught in the classroom, right? And we directly mug up the concept, okay? And if little modification is done in the examination, so we fail to get the correct answer. That's what happens mostly you know with the aspirants. So I'm just going to tell you something related to this question, okay? So that if in coming future, like in upcoming gate examination, if you're gonna face the same question, okay, or any concept related question, okay, and if they will change you little bit of change they might make, okay, so you should be able to solve that, right? So I'm just going to suggest, okay, so this question was asked in GATE 2024 in electronics and communication paper, and this question was for 2 mark, okay, and it is a MCQ question, right? So only one option is gonna be correct, okay, and the topic is nothing but priority encoder, okay. So I believe everyone might be familiar from the classroom, from my classroom, is that encoder has some sort of limitation, okay. Encoder has some sort of limitation. What kind of limitation encoder has, that you should know first, okay. Before you dive into priority encoder, you should know what are the limitation of the encoders. Let's say that if encoder has got the input more, input, if encoder has got more than one input high, okay, so encoder cannot give you the output, right? It cannot encode, okay. That is the very simple problem that encoder has, okay. Means one input should be active at a time. There should not be more than one input they are active, okay. If more than one input are active, okay, then you cannot expect any output in case of encoder, right? So to overcome this challenge, okay, to overcome this challenge, you know what we are going to do here is we are going for priority encoder. But in case of priority encoder, you know more than one input can be active high, okay, more than one input can be high, and then we can expect some output, right? But there is a logic, okay, there is a rule called, okay, we have to prioritize, okay, the inputs, okay. So a 4-bit priority encoder has inputs D3, D2, D1 and D0. In the classroom also, we always teach, in fact, uh, we have to make sure the priority, okay, the kind of level of priority that we are going to give, or you can say highest priority, we always give to D3, right? And then we decrease the priority, okay. The least priority is going to be given to D0, okay. So in this question also they have mentioned this language, okay. So that is according to the classroom only, right? But I will tell you where they have given a little modification, okay. So a 4-bit priority encoder has input D3, D2, D1 and D0, okay, in descending order of the priority. Means D3 has got highest priority and D0 has got least priority, okay. The 2-bit output AB is generated, okay, that is same, okay, whatever notation we use in the classroom, the same notation they have also used here. The 2-bit output AB is generated as, so let's say that D3 has got the priority, right? I mean D3 has got highest priority, okay. So the input when D3 is going to be high, okay, when the D3 is going to be high, so you are going to get the output as 0 0. Remember that. But in classroom, what kind of output we were getting? If D3 has got the highest priority and it is high, active high, you can say, okay, if the input is D3 is high, then output we were getting as 1 1, right? But here they have changed little bit, okay. They have just reversed the output, okay. They have reversed the mapping of the output, right? Now they are not following the way we follow truth table, right? 0 0 0 1 1 0 1 1. They have reversed it, okay. So that was only the change in this question. Otherwise this question was amazing, and many students, right, most of the students were not able to solve this question, I'm pretty sure, okay, because there was little modification. If you understand the concept, then you can solve this question, right? So let's move ahead. Let's solve this question properly. Okay. So what I'm going to do here is we are going to construct a priority table, right? Okay. Whenever there is a question of priority encoder, so you have to draw or you have to construct the priority table, right? So what is the priority encoder table? Priority encoder table. Okay. The priority encoder table is important so that you can get the min term from there, and then using the min term, you can find out, the boolean expression of the output bit B is. Okay. So out of 4, one option is going to be correct. I'm just going to show you, right? How we can get the boolean expression for B. You see here, this question is asked, the boolean expression of the output bit B is they are asking. Okay, you have to find the boolean expression. So how can we get the boolean expression? Once you will construct the priority table, आपको priority table एक construct करना है. You have to get the min term for which the B is high, or you can say B is having 1, output as 1, right? Okay, in case of output B, right? Wherever the B is high, you have to take corresponding min terms and then use the K map. Since there are 4 inputs, right? D3, D2, D1, D0. Then you have to use 4 variable K map where 16 cells are going to be there. Just fill the cell with 1, and then just make the grouping of ones, and then you can get the minimized expression. That is what every time we do in case of you know a combination circuit. Whenever we try to design a combination circuit, or you can say a cyclic combination circuit where no cycle is present, okay, we always go from input to output. Okay, so we always do this, right? So let's do ahead. So this was the talk just to explain you, right? So in case of encoder, there was a limitation. Okay, in order to overcome the limitation, we study about priority encoder. Okay, so remember that how we switch from one topic to another topic. Okay, this is given in the syllabus. This is important for gate examination. It is okay, but you should know why we are studying this priority encoder topic, right? Let's move ahead and solve this question. So priority encoder table, what we can do here is we can write D3, D2, D1 and D0, right? These are the inputs. And then here I'm going to write AB as the output. Okay, understood? And one more, there was one more thing, that was status line, you can say, right? Status line. Okay, so status line has to be 1, then only you will get some sort of output, right? That is very important to keep in mind. So let me say that let's say that input is 0 0 0 0, right? Okay, if everything is 0 0 here, okay, so output is gonna be 0 0 only, right? So all the inputs are 0 means we are not giving any sort of priority, right? No priority is given to, okay, AB. If no priority, or you can say least priority or no priority, okay, you can consider as same. So no priority, okay, no inputs are high, so outputs are going to be what? So output is going to be, you can see in the question only, that is going to be what? 1 1, right? That is very important to keep in mind. Okay, when you are constructing the priority table, priority encoder table, okay, so no inputs are high, okay, you can see here. Okay, so we don't have to give any sort of priority here, so output is going to be 1 1. Okay, I think this is clear, right? And then you can forget about this as no problem. Okay, just focus on priority input and output, that's it. Then what you can do here is, now we are going to make input high, D naught is high here, right? And since we know that D naught has got very less priority, okay, the priority is in this direction, in the descending order, right? Okay, so this guy has got highest, you can say, priority, and this guy has least priority. If it has least priority, so again your output is going to be 1 1 only, right? Okay, your output is going to be 1 1. I think this is clear, right? Next, what we can do here is, now we are going to make it as a don't care, right? Okay, because this is having least priority, so we can make it as a don't care and just going to keep 1 here, right? Okay, I think this is clear. So this guy, this row, you can say this row of the table is going to correspond to min term 1. You can say min term 1. Okay. I hope this makes sense. The very first row, you can say, or you can say also that the very first row of this table, the very first row of this table. Okay. Let me put this row correspond to m naught. Okay, the min term is going to be m naught. Okay, and the second row is going to be corresponding to m1, the min term as m1. Okay, I think this is clear for all. And then this has got, okay, why we are putting don't care here, because this is having least priority. Okay, so priority encoder is going to give this input as d naught as cross. Okay, you can say don't care. Don't care means it can take 0 or 1. So so there will be 0 0 1 1 or 0 0 1 0. So 0 0 1 1 means the min term is gonna be 3, or you can say 2 and 3, right? 1 0 means 2. So this row corresponds to min term 2 and min term 3. You can say it like this, okay? Because this don't care takes 0 or 1, right? It can be 0 or 1, okay? Now, so if this has got what? If this has got the active high, you can say D1 is high here. So what is going to be the output, right? So it is going to be nothing but, so earlier what we were doing in the classroom, we were putting the equivalent of 1, right? The binary equivalent of 1, okay? The index is 1, so binary equivalent is 0 1. But now we have to follow the question. So if D1 is going to be high, you see here guys, if D1 is going to be high, so your output must be 1 0. Very important to remember, 1 0. I think this is clear for all, right? Now you don't have to write the binary equivalent of index 1, okay? It is the point where you have to be careful. And this is what we always miss, okay? Because what happens in most of the coaching classes, you guys might have seen that you guys always focus on whatever teacher taught you, right? And you never think about yourself, that how you're going to approach to that problem, right? And that is where the ECS Academy comes into picture. Okay, that is where the Dheeraj sir comes into picture. Okay, he always opens up your eyes. Whatever question you take, whether it is a question from analog, digital network theory, you give me any sort of question, my approach is going to be different. Okay, so you see here now D1, if D1 is high, your output is going to be 1 0 according to the question, okay, given, right? Please follow that. I understand that you know what is priority encoder, whatever you have been studied in classroom, okay, at ECS Academy. But please follow the question, because IIT professor might change, they might reverse things, okay, in your life. Understand? I hope this makes sense. And this is one of the very good question. I really get excited to solve such kind of question. So 0 0 1 0. Next, move to next question. Okay, I mean, move to next. So it is going to be now having least priority. It is also having, least priority, and now it is going to be 1, right? We are just shifting 1 to the left, you can say. So now if D2 is high, D2 is high here, right? D2 is high. So in the classroom we used to write equivalent of 2, right? The binary equivalent of 2. But now if D2 is going to be high, right? So your output is going to be 0 1. So they have given here 0 1. Now what we can do here is, they have got no priority here. Now it has got highest priority. So we are going to write 1 here, right? We will find what are the corresponding min term we can get from this row, and what are the corresponding min term we can get from this row, right? Okay. Min term is what, right? So if D3 is high, right? So output should be 0 0. That is very simple. Now everything is reversed. This priority encoder table has got reversed output, right? From the classroom. Okay. In classroom we used to get 0 0 0 0, then 0 1, then 1 0. Can you recall that? Please check your notes, match the solution. You will find difference in the output, right? This part is going to be similar, whatever you have written in your notes. but output is going to be different. I believe this is fine for all, right? So what you can do here is, now what they're asking in this question, they're asking you to find the expression for this guy B. I will tell you how to find that expression. Okay? But let me talk about what are the possible, min term which you can get from this row. Okay, the row number 4 you can say. So here this has got don't care, right? So if it is one, it is one. Let's say this is one, this is one, right? So you can get 7. The maximum min term is going to be 7. Okay, and 7 you can say, and otherwise the smallest is going to be 4, right? So you can say that it is going to give you M4 to M7. Okay, now this can give you what? This can give you maximum, it can give you minimum, it can give M8 min-term index, and the maximum it can give you M15, because if all guys are 1, right? So you have got all the min-term. Okay, now what is the next job, sir? The expression for, expression for B, I'm just going to find, right? So since we have got 4 variable, right? Okay, so 4 variables are there. Your B is a function of 4 variables. So I'm going to choose 4 variable K map. So I have talked about everything in the playlist. I think many of you might have seen my playlist on K map. So you should not take much time to draw it. So this is D3, this is D2, this is D1, this is D0, 0, 0, 0, 1, 1, 1, 1, 0. 0 0 0 1 1 1 1 0, right? So you know that K map always follow adjacency rule, right? Now whatever minterms are present, okay, and corresponding to that the B is high. You see here, this is 1, this is 1, this is 1, right? So here M0 is high, right? So you can put here, so I think yeah, here M0 is high, M1 is also high, right? You can see here in the, M1 is also high because there is 1, but M2 and M3 is not high, so you don't have to write anything. M4, M7. Now 4 to 15, everything is gonna be high. Not in fact, they haven't given, 8 to 15, right? So 4 to 7. Okay, you have to just choose 4 to 7, right? So 4 to 7. So 4 is where this is gonna be 0 only, 4. So 0, 1, 2, 3, 4, 5, 6, 7. Okay, that's it. Okay, and nothing is, okay, this is meant for B. Okay, these are the minterm where, output is gonna be high, right? For which, so what you can do here is, now you can just group these ones. ठीक है, तो आप इनको 1 को, तो यहाँ पर सबसे बड़ा आपका जो grouping of 1 आएगा, that is gonna be your kind of prime implicant. Okay, so this is the first one, first term, and here you can also make the quad, right? So second. So what you can do here is, since, if you're moving in this direction, right? So all the variables are changing. You can forget all the variable. Only whatever is not changing, you can take. So this will give you D3 bar D2, right? And this is going to give you what, guys? If you move in this direction, so what is changing here? D2. If D2 is changing, forget D2. Whatever is not changing, take it that, right? So it will give you, you can say D3 bar, right? Because D3 is 0, and we have studied in classroom that, yeah, if 0 meant for complement of the variable in case of SOP, right? Sum of product. Now in this direction if you move, right? So whatever direction you are moving, right? And if any variable is changing, if it is changing from 0 to 1, you have to just forget it. Don't consider. Okay, so in this direction D1 is not changing, so you can say that it gives you D1, okay, bar, right? So can we take now? Can we take, right? So your B expression is gonna be in terms of D3, D2, D1, and D0, right? It is going to give you what? It will give you D3 bar D2 plus D3 bar D1 bar. Okay, I think this is clear, right? So you can just take D3 out also. So which option is gonna be correct now? Let me go back to the question and find it. Yeah. So I think B is correct answer for this question, B, and you will get 2 marks. Okay. So I hope you might have understood, my solutions, you might find it different, and we have taken 20 minutes to explain you, but we can solve this question in couple of minutes. Okay, you have to draw the priority table and then use the K map, answer the question, right? But I wanted to convey some masses, and from this video you're going to learn many things. First of all, you will come to know why we study priority encoder, right? Okay, because priority encoder allows more input to be high, and if inputs are more than one inputs are high, still priority encoder is going to give you some output, right? Okay, giving the highest priority to you know MSB. Okay, I hope this makes sense, right? So this is how you have to study. So priority encoder is studied to overcome the challenges that we face, or to overcome the limitation that we face in case of encoder. Okay, don't go through the topic like, okay, this is a topic encoder, ये priority encoder होता है, इसको ऐसे करते हैं वैसे करते हैं, और एग्जाम में थोड़ा सा चेंज अगर आ गया, अगर आपको रियलिटी नहीं पता है इस टॉपिक की ना, तो gone. And this happens in GATE 2024. Those who were good at some subjects, okay, they were able to get some marks, and this year a person who got less mark also, his rank is boom. Okay, like if somebody has got 57 marks, their rank is 55 rank. Okay, you imagine. And in my days, if someone has got 40 marks, their rank used to be nearly 4,000, 5,000. But now, if you got 40 marks, your rank is 1100 or 1000. Okay, and you're able to get the IITs. So please keep preparing, guys. I'm gonna upload all these solutions of previous year. Okay, from 1987 to 2024 in this YouTube channel for all the branches, not only electronics and communication. I'm going to upload for electrical engineering, instrumentation, data sciences, computer sciences. Okay. Thank you. We'll meet in the next video. Thank you.